my name is Mr. Percy Siwa. I come from Zimbabwe.
Oh, welcome, Mr. Percy.
Thank you. And I'll be taking you for maths. And today I want to talk about the symmetry of geometry. This is a very good and interesting subject because we get to see things that we experience and we handle each and every day of our lives. So, a line of symmetry is an aspect of this topic. A line of symmetry is simply a line that divides any object into two halves, such that the two halves they match each other. And we have got the keywords that we shall come across today. We have got line of symmetry and we've got the middle line and vertex. So the middle line and the symmetry of line are the same. So without much taking of time, we have got different shapes which are here. These different shapes, we shall analyze them each by each so that we can see how many lines of symmetry does each shape have. So we can start by a triangle, we've got a square, ellipse, a diamond. You know the diamond, the most precious stone. We also have got a circle, everything, you know a circle that we have. A bow is a circle, an orange is a circle, anything which is circular. We have got the rectangle, a star in the sky, and our hearts. So as we go on today, let's start with the triangle. This triangle is called an isosceles triangle. Two sides are equal. So since two sides are equal, we shall analyze this one today. And you go home and analyze other triangles. So this triangle, let's try from this vertex going down. From what we can see that we've got this half and this half, they are equal to each other. So which means this is the line of symmetry. For example, you take out your colored paper, you cut it by scissors and you make a rectangle, a triangle. So if you fold it by the middle through this vertex, you find that you've got two equal halves of the triangles. So this is what you call a line of symmetry. This line, this imaginary line here in the middle is called line of symmetry. So you can try any vertex going down or any vertex going any other side to analyze this. So this triangle has given us one line of symmetry. The next one is the circle. The circle is interesting. It does not have a vertex. A vertex being a point whereby two lines, two segments meet. So this circle has got infinite number of lines because it does not have no vertex. So the first thing that you do given a circle or an ellipse, because they are relatively the same, you put a center in the middle. And from your center, you can make a line of symmetry. This line of symmetry can tell us that this half and this half, they are equal. And if you go this side, horizontally, you've got two halves which are equal also. So any direction you shall take from this circle, you have got infinity number of lines of symmetry. They don't end as long as they are passing through the center. So the same applies for the ellipse. From the center, you can have this line, this line, this line, this line, making this half and this half, making this half and this half. So we have got infinity number of lines of symmetry. The next thing that you go on to do to analyze is called the square. So the square is given like this. So the square, having our square like this, I've cut this square for you, having a square like this. If we try to fold it in the middle, we can have the line like this, which shows that the upper half and the lower half, they are equal. So this is a line of symmetry. And then if you go from the top down, we've got this half and this half, they are equal. So we've got a line of symmetry also. And let's try to analyze from this vertex down this vertex. Can we have a line of symmetry? I'm pretty sure yes. Let's do a line of symmetry. This. So you can see this half and this half, they are equal and they match each other. And also it implies from this side. So we can say a square has got four lines of symmetry. So a square is relatively the same as a diamond. Given a square like this, The diamond is like this. So as we can see here now, we have got a diamond. So this diamond, we can say from this vertex running down, we have got a line of symmetry. These two halves, they are equal. And also from this side, we have got this half, upper half and lower half, they are equal. Taking the side from this vertex, we have got this half and this half. These two are equal also, which tells us that this is the line of symmetry. And the last but not the least, we have got this line like this. So you have got 4 lines of symmetry on a diamond. And then we have got to go on to the next one, which is the rectangle. The rectangle is interesting. You may want to relate it to the square, but it's different. Let's take a look at the rectangle. The rectangle has got a line of symmetry like this. This half and this half, they are equal. And if you go on from top to bottom, we have got this side and this side, they are equal. So these two sides are equal, which tells us that we have got a line of symmetry, like from this, we have got a line of symmetry. And if we fold our paper, we have got a line of symmetry also. So let's try to look at, can you put this vertex up to here? What we're doing it, like from relating to the square. Taking this point to this point, it comes onto a point like this. But it will not give us a vertex, because this line will be like this, and this other one will be matching down this side. So it won't give us a vertex. So the rectangle has got 2 lines of vertex, because you cannot move this side to this side. It won't give you a very good shape. It won't give you a very good shape. As you do the practice through the colored papers, you can see that you won't get a shape. You won't get a shape through a rectangle from this end to this end. We have got a star. We all have stars because they are all stars. A star, you've got 5 vertices. 1, 2, 3, 4, and 5. So from the first vertex, let's make a line down so that we can see that we have a line of symmetry. So from this, we can simply say we have got a line of symmetry from this vertex running down. This half and this half, they are equal to each other. So this is a line of symmetry. So we can take it from any vertex and try to see if we have a line of symmetry. So from this vertex to the other side, we've got a line of symmetry. And from the other vertex down here to the top, we have a line of symmetry. And we have got a line of symmetry. So a star will give us 5 lines of symmetry. And this one also will give us a line of symmetry. So that's what you do. So we will explain everything else, and as we do an activity through cutting the colored papers to make us the shapes. Last but not the least, which is the very good one, all of us have got a hat. So this is a hat. And on this hat that we have, how many lines of symmetry do we have? A simple way to make a hat is to just say you hold your fingers like this. This is the sign of a hat. So the line of symmetry is in the middle like this, which gives us the 2 equal halves. So from this point, we have got this line of symmetry, which cut the hat into 2. So we have got this half and this half. So we've got 1 line of symmetry for a hat. So as we go on to analyze everything, to make it easy for us, we can just take colored papers, you fold them into any shape using your scissors and cutting it, and to make also a shape, and if the 2 sides match, you've got a line of symmetry. Thank you very much for your time, and have a great day.